We are going to look today into how many solutions does an inequation in two variables have and how do we represent the solutions. If we consider the inequation x plus y smaller or equal than 5, we could find a pair of variables x, y that will fulfill the inequation. Like for example, if x is 1 and y is 2, 1 plus 2 is less or equal than 5. So this one is a good one. Or we can find, for example, 2 and 2. 2 plus 2 is less or equal than 5. Or we can find minus 10 and 7. Minus 10, which is x, add 7, which is y, is smaller or equal than 5. So this one is a good solution as well. There are some which will not be solutions, like for example, x equals 10, y equals 2. This is not a solution because x plus y is not smaller or equal than 5. So how many solutions can we find for this inequation? Obviously, the answer is infinitely many. Any pair of numbers that add up to a number less or equal than 5 is a solution. So the question is, how do I represent all these solutions? As we have two variables, it's normal to look at the coordinate system, having the variables x on the x-axis and y on the y-axis. My first step will be to look at where x plus y is equal to 5. So I change the inequality sign into an equality one. Now we remember that x plus y equals to 5 is an equation of a line. How do we draw a line? We need 2 points. Like for example, if x equals 0, y is 5. It's 1 point, x plus y is 5. If x is 5, y 0 is another point. So you can generate as many solutions as you want using a table of values. We've done this when we graph lines like 1, 4, 2, 3, and so on. If I plot those points, 0, 5, 5, 0, it's enough to have 2, but I can continue to plot the others. So all points where x plus y equals 5 will be on that line. So on that line, x plus y equals 5. The x coordinate of each point on that line plus the y coordinate of the point will be 5. Now this line divides my region, my plane, into 2 regions. For one of them will be x plus y will be smaller than 5. For the other will be x plus y is bigger than 5. So I need to decide which one is what. Is here x plus y smaller or bigger than 5? And the other one will be the opposite. In order to do that, we will take some points to check. So let us remember that we want to solve or to represent the inequality x plus y is smaller or equal than 5. If we take this point has a coordinate 0, 0. 0 plus 0 is smaller or equal than 5. So this is a good point. You can keep taking other points, like for example that one. That point has a coordinates negative 2, 2. For that point, x plus y is 0, which is less equal than 5. So that's a good point too. No matter what points you take in this region, x plus y will be smaller or equal than 5 for all points here. Yeah, actually x plus y will be smaller than 5 for all points in this region. Therefore, x plus y will be bigger than 5 for all points in this region. The way we decide, again, is just taking an point to check. I need to solve or to represent the inequation x plus y less or equal than 5. Therefore, I do not need this region. I want that region. This is a good region for me. So I'm going to shade that region because it's not part of my solution. and the one which is left, it's my solution. So we decided that in this region, x plus y is smaller than 5. However, sometimes I need to solve x plus y smaller than 5, and other times x plus y smaller than or equal to 5. So how do I represent one is versus how do I represent the other? If the line for x plus y equals 5, it's a solid line, and I shed the region that I do not need, then this is a representation of the inequation x plus y smaller than 5. So for smaller or equal than 5. So for x plus y smaller or equal than 5, I need a solid line for the x plus y equals 5 for the line. If I want to represent the equation x plus y smaller than 5, I need a dotted line. And my region will be represented like this. This shows that the points on that line are not included. In this question, I'm asked to describe the unshaded region. So I can see the border between the two regions, x plus y is equal to 6, meaning that my two region will be x plus y smaller than 6 and x plus y bigger than 6. Now I need to decide which one is what. Because the line is solid, then my region left will be smaller or equal than or bigger or equal than. To try this, I take a test point. So this one, because it's easier, 0, 0 is my test point. You can take any point that is not on the line. So for my test point, x equals 0, y equals 0. X plus y is 0, which is smaller or equal than 6. Therefore, in this whole region, x plus y will be smaller or equal than 6, same as for this point. All points have the same condition. So the answer for my question will be x plus y bigger or equal than 6, because I need this region. So this is unshaded region and is described by this inequation. Let us try to describe the region left unshaded here. Again, my border line is x plus 2y is equal to 8. Therefore, in one of the regions, I will have x plus 2y smaller than 8. In another region, I'll have x plus 2y bigger than 8. So I will need to see what region is the one unshaded. For 0, 0, x plus 2y for this point is x is 0. For this point, y is 0. So x plus 2y is 0 plus 2 times 0 is 0, which is smaller than 8. Therefore, my answer for this region is x plus 2y smaller than 8. In some cases, you do not see the equation of the borderline. So this is a borderline between the two regions, but I don't see its equation. However, I remember how to find the equation of the line to these two points. So the gradient of the line is rise over run, which is I go 3 units down and 9 units to the right. So it's going to be negative 3 over 9. Which is minus 1 over 3. So the equation of my line is y equals mx plus c, and c is 3, it's a y-intercept. I see it here. Yeah. So the equation of my line will be, and this is how I'm going to leave it, y equals minus 1 over 3x plus 3. Now I need to decide which one is the unshaded region. However, it's easier because I see this point 0, 0. It's easier to decide about that point. So if I replace 0, 0 for this point, y equals 0, x equals 0. So if I replace them there, I get 0 is y, and on the other side is minus 1 over 3 times 0 plus 3. This right hand side is 3, so 0 is less than 3. meaning that for all the points here, y will be less than minus 1 over 3x plus 3. Therefore, the unshaded region is y is bigger than negative 1 over 3x plus 3. And this is going to be your answer. Sometimes you're asked to decide for vertical or horizontal lines. So in this case, remember that this line has the equation x equals 2. If you take this point, for this point of coordinates 0, 0, x is 0, and it's smaller than 2. So all this region is x smaller than 2. See, if you go around, all the points here will have their x coordinates smaller than 2. Because that line is a solid line, my answer to this problem will be x smaller than or equal to 2. This is the unshaded region. Let us now look at this question. The equation of the line is y equals 4. We want the unshaded region, and if we take a test point, like for example that point, might have the coordinates 1, x equals 1, 5, because it's above 4, and this is a good point. So because it's in an unshaded region, therefore the equation of the unshaded region, or the inequation, is y bigger than 4. I will not take bigger than 4 or equal to 4 because the line is not a solid line. Sometimes we are asked to shade the inequation, and let's take an example. Let's say x bigger than or equal to 5. My first step will be to draw the line given by the equation, so I'm going to change this into x equals 5, and the line x equals 5 is this one. I'm going to draw it as a solid line because my inequation is bigger than or equal to, so this equal to tells me that I need to shade to draw a solid line. And now I need to decide which region has x coordinates of the points bigger than 5. Kind of, you see, if you look at the points here, you see that the x coordinate here is bigger than 5, so this will be your solution. But you might have to follow the instructions. The way I do it is just take a test point. Let's say we take this point, and this point has the coordinates 12 and 2. The x coordinate of this point is 12, and x is bigger or equal than 5. 12 is bigger or equal than 5, so this is a good point. Together with this point, all the region is a good region, and I need to shade the other region because it's an unwanted region. So this will be my solution, the unshaded region. How about if I want to represent the solutions of this inequation? First, I will change it into an equation, y minus 3x equals 4, and I'm going to find some points on the line, like for example for x equals 0, y minus 0 equals 4, so y is going to be 4. For x equals 1, if I replace x equals 1 here, I get y minus 3 is 4, so y needs to be 7. For y equals 2, I get y minus 3 times 2, 6. Y minus 6 is 4, so y will be 10, and so on. My points will be 0, 4, 1, 7, and so on. I can't represent 3, 10 because it's outside my grid. So this is going to be my line. And now I need a test point. Oh, my line needs to be a dotted line, so not a solid line, because my inequation is y minus 3x bigger than 4, so I don't need to include the points where it's equal to 4. I'll take my test point, so the easiest to take is 0, 0 as a test point. So x for this point is 0, y is 0. If I replace into y minus 3x, y is 0, x is 0, so my answer is 0, which is smaller than 4, is not bigger than 4. Therefore, this one is not a good point, because for this point, y minus 3x is not bigger than 4. So that's a bad point. Together with the whole region will be a bad region. So I'm going to shade this region because I do not need it. The unshaded region is my answer. This will be the last example, so you can pause the movie and try to do it by yourself. Let us change this one into an equation, y equals to x minus 3. I need some points. X equals 0, y equals negative 3, x equals 1, y equals negative 1, x equals 2, y equals 1, and so on. Drawing the line, x equals 0, y equals negative 3 is first point. Second point, 1, negative 1. Third point, 2, 1, and so on. So now I need to draw the line by joining the point with a dot line, because y should be bigger and not bigger or equal than 2x over 3. I now need to decide which one is a good region. In one of the regions, y will be smaller than 2x minus 3, and in another, y will be bigger than 2x minus 3. So which one is my right region? Let me take a test point. So if 0, 0 is my test point, so x equals 0, y equals 0 for my test point. If I replace here 0, and in the right hand side I have 2 times 0 minus 3, 0 is smaller than negative 3. No, this is false. 0 is bigger than negative 3. So 0, 0, it's a bad point. Therefore, together with this point, I need to shade the whole region, and the region unshaded will be my solution.